Hey everyone, and welcome back to the channel. Today, we're tackling LeetCode problem number 11, container with most water. This is a classic interview question, often categorized as a medium-level problem. The challenge is this: you're given an array of non-negative integers representing the heights of vertical lines. These lines are all spaced 1 unit apart. We need to find two lines that, when connected at the top, form a container that holds the maximum amount of water. The area of the container is calculated as the minimum of the two line heights multiplied by the distance between them. Think of it like building containers using vertical boards. We need to find the pair that holds the most water. The output should simply be the maximum area we can achieve. So let's dive into the problem. We'll break down the solution step by step. Understanding with examples. Let's work through a couple of examples. Imagine we have an array 1, 8, 6, 2, 5, 4, 8, 3, 7. If we pick the first and last lines, the height is limited by the shorter line, height 1, and the width is 8 units. The area is 1 times 8 equals 8. Now let's try lines at positions 1 and 8. The heights are 8 and 7, so the minimum height is 7, and the width is 7. The area is 7 times 7 equals 49. See how this is already larger? Notice that the key here isn't just choosing the tallest lines. It's about finding the right balance between height and width. That's the core challenge of this problem. Let's try another example with a smaller array. 2, 3, 4, 1. We need to systematically explore all possible pairs of lines to find the maximum area. We'll see how to do that in the next section. Brute force approach. A simple but inefficient approach is the brute force method. We could iterate through all possible pairs of lines in the array and calculate the area for each pair. We would compare each area to our current maximum and update it whenever a larger area is found. The code would involve nested loops, each iterating through the indices of the array. This means comparing every line to every other line. While straightforward, this approach has a time complexity of O of n squared, where n is the number of lines. This becomes incredibly slow for large arrays because the number of pairs to check explodes. Therefore, we need a more efficient way to solve the problem. Optimal solution. The optimal solution uses a two-pointer approach. We initialize 2 pointers, one at the beginning and one at the end of the array. In each iteration, we calculate the area using the heights at the 2 pointers and the distance between them. Crucially, after calculating the area, we move the pointer associated with the shorter height inward. The intuition is that moving the taller height inwards is unlikely to yield a larger area. The shorter height is a bottleneck. By moving the shorter pointer inwards, we might discover a pair with a greater height and potentially a larger area. This algorithm cleverly reduces the number of comparisons needed dramatically. Optimal solution code implementation. Let's see the code in Python. We'll use the two-pointer approach. We'll start by initializing our pointers left and right. Then we'll iterate while left is less than right. Inside the loop, we calculate the current area, update max area if necessary, and then move the appropriate pointer. Here's the code. Def max area nums. Left, right equals 0, len of nums minus 1. Max area equals 0. While left is less than right, area equals min of nums left, nums right, multiplied by right minus left. Max area equals max of max area, area. If nums left is less than nums right, left plus 1. Else, right minus 1. Return max area. This code elegantly implements our two-pointer strategy, ensuring efficiency and correctness. Time and space complexity. The time complexity of our optimal solution is O of n, a significant improvement over the brute force method's O of n squared. This is because we only iterate through the array once using the 2 pointers. The space complexity is O of 1, as we only use a few constant extra variables. This demonstrates the power of choosing the right algorithm to solve a problem effectively. This makes the solution incredibly efficient for large inputs. Engagement break. So there you have it, a clear and efficient solution to the container with most water problem. Before we wrap up, don't forget to smash that like button if this helped you understand the problem better. Also, subscribe to the channel for more LeetCode solutions and algorithm tutorials. Let me know in the comments what other LeetCode problems you'd like me to cover next. Conclusion. In this video, we tackled LeetCode problem 11, container with most water. We explored a brute force approach and then implemented a much more efficient solution using a two-pointer technique. Remember, the key to this problem is understanding the interplay between height and width when calculating the area and how to strategically move the pointers. This problem is frequently asked in coding interviews, so mastering this efficient solution is a great